Welcome back to our final lesson on the unit circle. Here you see we have labeled the angles in degree and radian measure that we've learned from previous videos. Today we're going to talk about the coordinates of the unit circle. I would like to remind you that two things are true about the unit circle. If this was placed on a coordinate grid, it would be centered at the origin and have a radius of 1. I would also like to tell you that a radius is any length from the center to the outside of the circle. So that means all of these lines in blue are considered radiuses or radii. Radii is the more appropriate word for multiple radiuses. Radii. Right now we're going to focus on the x and y axis. So my center is at the origin, and if I move 1 unit to the right, that would put me at this point 1 unit to the right of the origin is 1, 0. So at 0 degrees or 360 degrees, the ordered pair for that point is 1, 0. Moving around the circle to my 90-degree angle, that is 1 unit above the origin, which is the point 0, 1. Continuing to 180 degrees, that would be 1 unit to the left of the origin, which is -1, 0. And then last but not least, 1 unit below, or 270 degrees, is the coordinate 0, -1. To fill in the remaining quadrants, or coordinates, we're going to focus on quadrant 1. Here I focused our unit circle on quadrant 1 and specifically want to talk about the first angle measure. The first angle measure has a terminal side at 0 degrees, an initial side at 0 degrees and a terminal side at 30 degrees. My goal is to find the coordinate of that point that is created by a 30-degree angle. Hopefully, 30 degrees reminds you of the special right triangle rules that we have seen in previous math classes. If you do not remember the rules for special right triangles, please refer to the video found on Monday's lesson. One way to utilize the 30-60-90 rule, or the only way rather to utilize the 30-60-90 rule, is to have a right triangle. So we are going to drop an altitude or a line straight down from the coordinate to my initial side so that I can create a right triangle. Now, the angle closest to the origin is 30 degrees. My second angle that I just made is 90 degrees, which means the angle at the top closest to the coordinate is going to be a 60-degree angle. This right triangle has a short leg, a long leg, and a hypotenuse. Now, this hypotenuse is of course considered a radius and has a length of 1 unit. Referring back to my 30-60-90-degree rules, I'm reminded that the short leg is half of the hypotenuse. The short leg is half of the hypotenuse. Well, if I want to be half of 1, that would be 1/2. To find the long leg of my hypotenuse, the long leg of my right triangle, I would multiply the short leg times the square root of 3. When we multiply fractions, of course, we would write it as square roots of 3 over 2. The numerator over the denominator. Now, that square roots of 3 over 2 represents the x value of my coordinate. It is the x distance from the origin to that coordinate. One half represents the y value because it is the distance above the x-axis. So the coordinate for the 30-degree angle is square roots of 3 over 2, comma 1/2. While we're thinking of these 30, 60, 90 rules, we're going to jump to the 60-degree angle. That's the angle made by the initial side on my x-axis, the terminal side 60 degrees above. And just like before, we're going to drop an altitude or a straight line from the ordered pair, the coordinate, straight down to the initial side in order to create a right triangle. Hopefully, you see the potential for a pattern that will emerge. Here we still have a radius of 1 because all of my radii are the same measure on a unit circle, on any circle. Since the angle closest to the origin is 60 degrees, the angle closest to the coordinate is now 30 degrees. So before we talked about the 30-degree angle, this angle down here was square roots of 3 over 2, comma 1/2. Notice now my short leg is the x-axis now. So my short leg is always across from the smallest angle. The 30-degree angle is at the top, so my short leg is going to be on the x-axis now, and that length is half of the hypotenuse. So now my x value is 1/2. The long leg of a right triangle is given by the short leg times the square root of 3. So that means my y value is going to be square roots of 3 over 2. So now the y value of the 60-degree angle is square roots of 3 over 2. It is the flip of the 30-degree angle because my short leg and my long leg have switched positions. Hopefully that will help when we're filling in the rest of our ordered pairs. Now let's move on to the 45-degree angle. My 45-degree angle is created by the initial side on the x-axis, the terminal side 45 degrees above. And just like before, we are going to drop an altitude straight down from the coordinate to create a right triangle. Now, since the angle at the bottom of the triangle closest to the origin is 45 degrees, this is a right triangle, that means the angle closest to the coordinate is also 45 degrees, which means these two side lengths have to be congruent. The other piece of information I know is that my radius is 1 unit long. Now, there are a couple different things we can do. We can use Pythagorean theorem, of course. We can use our right triangle trig, or we can use the rule for 45, 45, 90 triangles. In order to find the hypotenuse of a 45, 45, 90, you take the leg and multiply it by the square root of 2 to get the hypotenuse. So in this case, I know my hypotenuse. I need to divide by the square root of 2. So my leg will equal, I know my hypotenuse is 1, and I must divide by the square root of 2. Now, in previous math classes, we have discussed how we never leave radicals in the denominator. That rule still applies. So we have to rationalize the denominator. That simply means we're going to multiply the numerator and the denominator by the square root of 2. So when I multiply both the numerator and denominator by the square root of 2, that gives me square root of 2 over the square root of 4. Well, ladies and gentlemen, what is the square root of 4? 2, exactly. So this leaves me with a leg measure of square root of 2 divided by 2. I would like to remind you that even though there is a 2 in the numerator and a 2 in the denominator, they cannot cancel out because the 2 in the numerator is under a radical sign. Remember, we can't divide into a radical unless there's another radical. Inside times inside, outside times outside. The 2 in the numerator is inside a radical. The 2 in the denominator is outside of a radical. So they cannot cancel out. So each of my legs, my x value and my y value, are both square roots of 2 over 2. Let's put it all together. I would like for you to notice a couple of different things. First and foremost, we've already pointed out that the 60-degree quadrant, the 60-degree angle and the 30-degree angle, even though I circled them opposite each other, the 30-degree angle and the 60-degree angle have the same numeric values. They're just in different positions. And notice that the 45-45 angle have the same x and y value. I would also like to point out that all 3 angle markers are all divided by 2. Everybody gets divided by 2. Now, let's fill out the rest of the circle. We can go through and do our 30, 60, 90 triangles for every single angle within the unit circle. Because if I were to drop a altitude from this angle here, which would be 120 degrees this way, the rest of it would be 60 degrees. Therefore, it would have similar coordinates as the 60-degree angle in quadrant 1. 1/2 comma, square roots of 3 over 2. The only difference is I'm in the second quadrant, which means my x value is negative. Going to the next angle, I could draw a right triangle. At the 45, it would be 135 degrees all the way, so this little guy here would be 45. It would have the same or similar coordinates as the 45 in the first quadrant. Square root of 2 over 2, comma, square root of 2 over 2. The only difference is, again, we are in quadrant 2, so the x value is negative. Last but not least, I could draw a triangle at 250, but I know that this inside angle is actually only 30 degrees, so it would be similar to the 30-degree angle from quadrant 1. Square roots of 3 over 2, comma, 1/2. But again, we're in the second quadrant where the x values are negative. Notice all I did was reflect these points across the y-axis. Reflection is something we learned about in the first unit at the very beginning of Math 2. But it is something that is very useful here. Instead of doing all of the 30, 60, 90, and 45, 45, 90 triangles again, I can just take quadrant 1 and reflect it over and over. For example, if I reflect the point negative square roots of 3 over 2, comma, 1/2 across the x-axis, it creates this triangle here, which is a right triangle and has similar quadrants, square roots of 3 over 2, comma, 1/2. The only thing you've got to pay attention to is the fact that we are in the third quadrant, so both my x and y are negative. Reflect the next point. The next point reflects to the middle, or 225 degrees. Has similar coordinates, square roots of 2 over 2, comma, square roots of 2 over 2. But again, we're in the third quadrant, so both coordinates are negative. Last but not least, reflect the purple triangle to land on the 240. So we have the similar coordinates, 1/2, comma, square roots of 3 over 2. But again, we're in the third quadrant, negative, negative. Now we can reflect again. Reflect 240 across the y-axis. So 1/2, comma, square roots of 3 over 2. But now we're in the fourth quadrant where the y value is negative. Reflect square roots of 2 over 2, comma, square roots of 2 over 2. Y value is negative. Reflect square roots of 3 over 2, comma 1/2. Y value is negative. And if I were to reflect again, the green would land on green, the yellow would land on yellow, and the purple would land on purple. A reflection again. I've essentially made 3 very colorful rectangles. Be careful when you're reflecting that they line up, that you're reflecting across the X and the Y axis. Also, be very cautious when you are writing your ordered pairs, especially if it has a square root symbol in a negative quadrant. Make sure your negative doesn't accidentally look like it's an extension of the shelf with your square root symbol. Please make it very obvious for you and for me that it is a negative, not an extension of the shelf. See how easily that negative can be hidden? We want to make sure it is very obvious that we are talking about a negative value, not an extension of the shelf. Now, your homework assignment for today is to draw an accurate and detailed unit circle. I would like for you to make this large enough that you can see all pieces of information on one unit circle. Please do not draw 3 different unit circles. Please do not make this as teeny tiny as possible. My personal unit circle takes up an entire piece of paper. Please draw it accurately, take your time, and get a ruler. If you need to, you're more than welcome to grab a can of some sort to draw a beautiful circle. Make it as nice and neat as possible. Take a picture, send it to me via text or email, and I hope you have a wonderful day.